Hello everyone, and welcome to an exciting tutorial where we're going to be covering using the Python programming language to create video games. Video games, despite being fun and mostly for hobby, are actually some of the most complex and challenging things to code and program, especially in this day and age. So think about your favorite current generation games, something like Battlefield 4, Grand Theft Auto 5, or something like that, or maybe it is another game, but chances are all of these games that you might think of incorporate, first of all, just incredible graphics engines, impressive artificial intelligence, and pretty intricate physics, and that's just to start. Then obviously they've got plot lines and action and, user friendliness and all of this. But all these things are actually really, really complex things to code, each in their own right, and then to make a really great video game, you've got to combine all of those things. So naturally, this not only makes game development a fantastic topic to consider when learning a programming language, but it also makes it a very challenging topic to tackle because you have to learn about all of these things at once. So this is where Python can come in, and it actually helps to make the experience quite nice. So Python is fairly programmer friendly or fairly newbie friendly programming language, especially with its syntax. So even if you're not already an experienced developer in Python, or maybe you've never even programmed once in your life in Python, you should be able to at least follow along. But chances are, if you were to look at some code, besides understanding the purpose of functions and all of this, but you should be able to understand the syntax, what's happening. You've got while statements, and usually the while statement is pretty black and white. You understand what it's asking, an if statement, and that kind of thing. And then for loops, generally, unless they're written to be a little bit obfuscated, are generally easy to understand, or at least they can be written to be easily understood. So with that, it is somewhat expected that you have a basic understanding of programming, specifically with Python, throughout this tutorial series. However, if you don't yet know Python, or any programming language, the series might be a bit of a challenge for you, but you should actually still be able to follow along, and if anything, you can always just copy the code. But you should be able to follow along and actually understand what's happening, because again, Python is pretty user-friendly, and someone from the outside can pretty quickly grasp it. And that's why I think that Python is such a great language to start with, and learning to develop games is actually a pretty good way to embark on your journey as a programmer, because it will cover a lot of topics. It's actually somewhat exciting and rewarding to make your first video game, and so obviously that's good. So for Python, we're going to be using a module called Pygame. Now also, since I assume most people understand or have Python already installed, and because they've used it before, I assume that most of you are in that scenario, but I know that some people maybe have not already got Python installed, so I'm going to run through that really quickly. So if you don't have it already installed, you're going to want to head to python.org, go to downloads, and then basically we're using Python 3, so download your specific, if you're not on Windows right now with me, chances are this looks a little bit different for you, but for whatever you're on, download your version for Python. Once you have it installed, it's pretty easy to use. For the purposes of this video, I like to program in the default Python IDE, and so for anyone that isn't sure what that is, you can go to your start bar and then Python 3.4, and then you click on IDLE, and that should bring up a window just like this. You could also search for Python, and you can bring up a window like this. Then what I do is I go File, New File, and that opens up a blank document. From here, I can go File, Save As, and then we can save something like here, example.py. We could save over that. So save as example.py, and now I've got a blank text document that I can start to program Python in. So for example, we could just have it print a real quick hello, and we can save and run that, and it prints hello to console. So this is the environment that we're going to be programming in, and that's how you can get into that environment. Other than that, not too much to say on Python. So let's go ahead and grab Pygame now. So head over to pygame.org, and this should be where you land. And then basically the same thing that we just did with Python, we're going to head over to Downloads. And this is where things are going to be a little bit different depending on what kind of operating system you're on. I happen to be on a Windows operating system, so I would probably use one of these Windows downloads. That said, the current version of Python is 3.4, and the most current version of a downloader that they have for Windows is 3.2. So this is not good, because unless you don't have to be intermediate or anything, but you have to know how to change setup path, because this is going to look for C:/Python 32, not 34. So luckily for us, a really easy remedy, and they actually list it right here on the page, and it's this right here. So you can head to this guy's website, and what he does is he creates these binaries for 64-bit Windows, but he actually has releases for more than just 64-bit. So we're going to head there now. And as you can see, we actually have the 64-bit up here, but then we also have the 32-bit installers down here, all the way up to Python 3.4. If you happen to be watching this after the fact, and maybe 3.5 is out, or 3.8 is out, or whatever, most likely updated on here. These come very quickly. Usually I see these quicker than the installer actually comes out on some of these places' websites. So anyway, it's a really great website. I definitely suggest that you go ahead and save this website somewhere, because it's not just for Pygame. It's for a whole bunch of modules. Pretty much all of the most popular modules you're going to find here. Basically all of these modules. So there's a lot of modules here. So anyway, if you're on Windows, we want to use Pygame. And well, I guess I could just re-enter this link. And so then you'll want to download whichever one you have. So either 64-bit Windows would download 3.4 or 32-bit right here, and download and install. Obviously, if you are on some sort of Linux distribution or Mac OS, then you'll want to download either using the source. You should be able to do apt-get Python Pygame. So download whichever way that you prefer to download. So anyway, with that, let's go ahead and get started here. So now we're in the IDLE for Python. This is the basic text editor / IDE for Python. And now we're ready to begin coding. Once you've downloaded and installed Pygame, you should be able to, in fact, hold on, let's make my text slightly bigger here. There we go. Once you have everything downloaded and installed for Pygame, you can go import and then Pygame. And real quick, go ahead and you can either go run and run module, or you can just hit F5, and you'll probably get one of these little boxes that tells you basically you need to save it. So we'll just hit OK. And just make sure that you can import Pygame. If you can't, it'll throw an error. So we'll say Pygame blah. Because we don't have that module, it's going to throw an error. It'll say like this, no module named. So if you incorrectly installed Pygame, you'll get something like that. So if you've correctly installed it, you won't have any problems. So let's go ahead and talk about some of the most basic things to Pygame and setting up our Pygame instance. The first thing that we want to do is we want to initiate Pygame and basically all of the other modules that come with Pygame. So this is necessary. It's basically as necessary as the import, and it needs to be the first Pygame action that you take. So without getting too in-depth into classes and object-oriented programming, it's just like a class where you have to initiate it. So we're going to go ahead and go pygame.init, which is short for initiate, and that's it. So we basically just say, hey, look, we're going to be programming with Pygame now. Let's go ahead and get everything started. The next thing is Pygame is going to come up with some sort of screen, okay? So we want to set our display, and we can pick the resolution of our display. And really the correct word for display is actually going to be surface, and because it's returning a pygame.surface object. So let's go ahead and we're going to use a variable and we're going to call it surface, and surface is going to equal pygame.display.set_mode, and then we have one parameter. So this is a function. Like I said, if you're not too familiar with Python, try to ease into what's happening. But then if you are familiar with Python, I don't want to hold everyone back. So we'll try to take this kind of quick. If at any time you kind of feel lost, you might want to hit the basics of Python again. But anyway, so we're defining the surface variable and it's equal to pygame.display.setMode. And all set mode is, well, with the first parameter anyway, is going to be a resolution, and it's going to be 700. And we're actually let's do 800 by 400. So it will be 800 pixels wide and 400 pixels tall. And note the double parentheses here. So this is the first parameter. So it's a tuple. Okay, so just make sure you have two parentheses here. So moving on, because like this is a whole parameter. If you didn't have it, it would treat 800 as a parameter and 400 as a parameter. Moving on, we probably going to want to like title the window, just like up here, like at the top of your window for Python IDE, it says Python the version and then the file name. We kind of want to do the same thing, only we're gonna name it the same name as our game. And so for us, the game that we're going to be making is just a basic game. It's kind of like Flappy Bird, which Flappy Bird obviously is not an original game. You've got Flappy Bird, which is kind of like a game called Helicopter. And there's just a bunch of helicopter type games out there, and the notion that most people understand nowadays is Flappy Bird. So you're just basically trying to avoid obstacles, and you can only the only command that you can enter is an upward motion, and then when you're not entering upward motion, you're falling. And so that's the idea of the game. And so our game, we're gonna call it Helicopter. So we're gonna say pygame.display.set underscore, and the word for this is caption. I'm not too sure why we want to call it a caption, because to me I think of a caption under a picture or something, but this is actually what's going to change our title for us, and we're going to call it Helicopter. Then we have a couple other things that we need for games. The first thing that we need for games that all games have is, besides board games I suppose, but all computer games, is frames per second. So we have to have some sort of thing that's going to measure frames per second for us and help us set frames and all of that. So for that, we use Pygame's time clock. So we're going to call this variable clock, and we're going to say it equals pygame.time.C clock empty parameters. And that's really it. We're going to be using this as a sort of to track time for frames per second, which we'll be adding in a little bit. So a typical game has what's called a main loop or a game loop sometimes, and that's where all the game's functionality comes in. And there's almost always with the same quit event handling somewhere in there. And so this main loop is going to contain the event handling, any quits, updates to the display. Sometimes you might hear what people call the game state. So it basically reflects, this loop is what sets the game state. And just basically it just means that all of the variable settings at the time, because at the end of the day this all just boils down to a bunch of variables that determine what we draw to the screen, and that's it. So we're going to make a main loop, or we call it sometimes a game loop, and this is typically, it just runs through the code many times a second. So if you had 30 frames per second, and your goal would be to run through that code 30 times per second. And then basically it's just going to be constantly checking for any changes and redrawing the changes that it finds. So let's go ahead and get started. For ours, we're going to have the first constant here as game underscore over, and we're going to say game over equals false for now. And so what we're going to have here is, while game over is false, we're going to keep playing the game, but at any point when game over is true, we don't want to be playing this game anymore. So then we'll come down here and we'll say while not game over, what do we want to do? So this is the initiation of a while loop, and basically a while loop is just while something is the case, do something, and we're asking actually here, while something is not the case, do something, so it will continue doing it until something changes there. And then we're going to use a for loop, and we're going to say for event in pygame.event.get empty parameters. So now this is a for loop, and a for loop, if you remember, is for x and y do something. So a lot of times it'll iterate through a list, and in this case that's exactly what it's doing. There's events that Pygame is grabbing for us, so this is all Pygame code here. And this is why making games in Python is so easy, because Pygame, the module, does a lot of work for you. So pygame.event.get is going to get all kinds of events, like where is the mouse on the screen, what keys are being pressed, and so on. And then whatever event it gets, it's going to save it to this variable called event. And then we're just going to ask a couple of questions. For now, we're just going to ask one simple one, and it's going to be if event.type double equal signs, so that means if it equals something, basically, because this is a comparison operator, the double equals. This would be just an assignment operator. So we're not assigning a variable or anything. We're saying we're trying to compare. And if the event type equals the same as pygame.quit, all caps. Then we're going to go ahead and say game_over equals true. And that will break this loop, right? So as long as game over is not true, so a while loop asks if something is true or false, it's Boolean. It keeps running, and eventually, if it finds an event that's equal to a pygame.quit, it will change this game over to true, and then this will stop running, and that's it. So that's all we have to do there. Pygame.quit is also a bunch of events. The main event for pygame.quit would be if you hit the X in your window and you X out of that window, that will initiate a quit for us. Now we're going to come down. We're still in this while loop because if this if is not triggered, now we're going to run the game code. So the first game code that we're going to run right now is going to be pygame.display.update empty parameters. And what this is going to do is it's going to update our display for us. It's important to note the difference between display.update and display.flip. Display.flip will update the entire surface, so basically the entire window. .update will just update specific areas on the screen. That said, if you don't pass a parameter, then display.update will update the entire surface as well. Basically, this makes flip pretty pointless for our interests, at least in a basic series. There might come some times when you might use flip for very specific tasks, but pretty unlikely for a while. And that brings up another point. With games, we just have this notion of movement, but there's actually nothing, there's no real movement happening. Flip is a better term. Games are a lot like flip books that just draw dynamically based on what has happened. So anyway, moving on. So we do display.update, and now this is going to update our clock, and or rather the update's going to happen, and then we want to update the clock. And so what we're going to use here is clock.tick, and then we're going to say 60. Now, depending on the type of game that you're developing, so in our case 60 here is basically meaning this game will be 60 frames per second. Now, depending on the type of game that you're developing, frames per second might wind up being very integral to the actual game, not just smoothness. So for the types of games that we're going to build, the game is almost entirely dependent on this engine and the frame refreshes to build this virtual environment. We only have one bit of user input, and that's it. Now, for all games, even the most complex games today, everything boils down to frames. And a frame is just the drawing on your screen or surface. It's a still drawing. And as I was saying, apparent movement is not actually movement at all, and all games are really just like a flip book, and they just respond to the variable changes in the code that kind of determine what's drawn to your screen. So think about when you lag in a game, is it just parts of the game that are lagging, or is it all of the game that are lagging? Well, of course, this is barring networked multiplayer games, right, that are experiencing network lag, but think more along the lines of single-player games where you've lagged. You know, everything lags because everything has to be drawn to the screen for the most part. So FPS today, or frames per second, is mostly used to measure smoothness. In general, anything between 20 to 30 frames per second is seen to be fluid by the human eye. Anything higher than 30 frames per second, for the most part, for the average human eye, there's really no difference that can be told. So you're really just wasting graphics computations, because if you've got 60 frames per second, you're running that main loop 60 times a second to generate all of those unique frames. So once our game has ticked, we're ready to quit, okay? And this is called at the very end, and this is actually, obviously for a few reasons. Pygame.quit will exit Pygame, so it stops the Pygame instance. So when we're out of this while loop, so we'll run pygame.quit empty parameters. Now, we don't want to call quit necessarily because of a game over. So maybe the player just wants to play again. Instead, we want to call quit when an action has requested that we completely exit the program. So far the only action that is triggered as a quit is the clicking of an X in the window to leave. But once that's happened, we'll do pygame.quit, and then finally we'll do just quit empty parameters. and that will exit our actual program as well. So now we're ready. Let's go ahead and go run module. It's going to ask us if we want to save it. Yes. We'll save it, and you should run it, and you get this window popped up. Nothing here besides our caption and this little logo. It's just a Pygame logo. Nothing else here, but you get this window. You can minimize it, and we can exit it out and all of that. We can move it around, and we can't see it right now, but it is logging the events that we are doing as we're holding our mouse over here and all of that. And then also when we're finally done, we can hit this X arrow here, and that exits, and then you're asked if you want to kill your program because it's asking to quit the entire program. We're going to go ahead and hit OK, and that exits the whole program. Now obviously there's still a lot of code for us to write, and this will be a stopping point for part 1, but in part 2 we're going to continue building on this, adding some more logic, getting our helicopter, adding things called sprites, which is basically just like an image, and getting some user input, controlling our helicopter, avoiding obstacles, and having some event handling for when we crash and all of that. So anyway, stay tuned for the next section here. Thanks for watching.